again. Pancake sorting is the next one. I don't know how long I want to go for today. So it looks like I usually give it a few seconds before I get going. Going. Hello. Yep. Working. Sweet. Yeah. I don't know, man. I'm like going through these questions, and it's just I'm kind of getting these memories, I suppose. Memories of a former life lived, I suppose. Former life. Pancake sorting. All right, let's look at pancake sorting. Memories of a former life, I suppose. And I'm sad about it. Sad. But that's okay. That's kind of starting a new thing anyway. New chapter in life. Not a new chapter, but it's really a new book, more like. Give an array of integers array, sort the array by performing a series of pancake flips. In one pancake flip, we do the following steps. Choose an integer k, where 1 is less than or equal to k is less than or equal to the array.length. Reverse the subarray array 0 to k minus 1, 0 indexed. For example, if array 3214, and we performed a pancake flip choosing k equals 3, we reverse the subarray 321, so array 1, 2, 3, 4 after the pancake flip at k equals 3. Okay, I have to read this a few times to understand. Return an array of the k values corresponding to a sequence of pancake flips that sort array. Any valid answer that sorts the array within 10 times array length flips will be judged as correct. Oh, okay. What? All right. 3, 2, 4, 1, output 4, 2, 4, 3. 4 flips with k values 4, 2, 4, 3. Starting state 3, 2, 4, 1. First flip 1, 4, 2, 3. What is the flip again? Choose an integer k, reverse the subarray. Oh, okay. Oh, all right. So the subarray gets reversed. That's what they call the pancake flip. So 3214, when you reverse the subarray 321, which is k equals 3, then you get 1, 2, 3, 4. Oh, I see. Interesting. Return an array of the k values corresponding to a sequence of pancake flips that sort array. Any valid answer that sorts the array within 10 times the array length flips will be judged as correct. Okay. So we have to sort it using the pancake flips. Oh, interesting. Whoa. And we have to do it in linear time. Well, the number of flips it's not really linear. The number of flips just has to be linear. I mean, can't you just get the smallest element, right? Get the smallest element and do a pancake flip that puts that smallest element in the right spot. And then do another pancake flip that gets the second element in the right spot. If it's already there, then you could skip it. And then now you got 3 and 4, and you just need to flip that. Oh, but you can't. But it goes left to right, not right to left. So actually, you'd want the largest value. Oh, but you can't really do that, can you? I want to get 4 to the end. Oh, I can't really do that, huh? Oh, all right. It's not so obvious how to do this. Maybe. Oh, I think I know what to do. No, I don't know. Okay. My thinking is you can do a flip, a reversal of a particular subarray if you first reverse the whole thing from the beginning to that spot, and then reverse. That doesn't work. Thinking like you do 3, 2, 4, Now you get 4, 2, 3. And then you reverse 4 and 2. No, that doesn't make sense, does it? I don't know. That's kind of tricky. Can you do it that way to move? Let's say if you want to move 1 to the left side, I mean, you could just reverse the whole thing, and then 2 is already in the right spot. But now you get, oh no, yeah, you reverse the whole thing, you end up with 1, 4, 2, 3, and then now I want, excuse me, how big is this array going to be? Only 100. Okay, that's not too bad. All the integers are unique. I think because there's only 100 elements, there are quite a few different possibilities you can go with. It'll be fast enough. So, okay, I don't know. You could do 1 reverse of the whole thing to get the 1, and you end up with 1, or you end up with, 1, 4, 2, 3. And now you want to get the 2 where the 4 is. So if you were to just reverse here and here, right? Or reverse 1 and 4, and then reverse, never mind, I don't know, this is like kind of confusing. Reverse the whole thing, puts the 4 all the way over there, and then reverse the 3, moves the 1 back. Maybe that's what I've got to do, is I've got to, when I reverse once, I get this 1 all the way on the left side, and the 4 ends up somewhere, and then now I want to put the 4 on the right side. So I move the 4 and the 1. No, I don't know. I don't know about this one. This seems hard. Seems challenging. I don't know. I'm trying to think about this one. I don't know the answer. I gotta really think about it. Yeah, it's not obvious. Because like what I'd normally want to do is like compound the operations, right? So that way, because each flip I do, each reversal that I perform, it affects the other reversals, right? And all of the reversals are always going to reverse at least 1 element at a time. Well, I mean, you can't reverse 1 element, but it always reverses at least 2 elements at a time. So it's not clear exactly what ought to be done. Maybe I can kind of find something by induction, like some kind of a greedy algorithm that works. Linear number of flips that will sort the array. Well, in order to sort the array, you could do kind of like the smallest element, you want to move that to the left, and the largest element and then the next smallest element should go to the right of that, and so on. So let's say suppose I had a partially sorted array. Let's do it that way. Let's try to do the inductive step. Partially sorted array. Somewhere to the right is the next smallest element. I can find it, right? Because this array is small enough where I can do certain things like that, for example. How do I get that to be in the correct spot? Well, if I reverse the entire array up to that point, right? Let's say I reverse the entire array up to that point. So let's say I have some I is the index of the last position of the sorted element. J is the position of the next element in the sort, and I want to move the value at index j to I plus 1, but also I want to have all the other values at in their respective positions. Well, if I reverse all the way up to j, what will happen is all of those values, j will now be in the first position, and all of those values will be in the basically sorted in descending order, starting from j minus I, more or less. Yeah, well, let's see. There would be, how many elements would there be at the index? Well, it would be I elements at I plus 1 elements at index I, right? And then from j, you would have j minus x plus 1 is equal to I plus 1, right? Where x is then going to be j minus x equals I, x is then j minus I. So yeah, it's going to be from index j minus I descending to j, right? That's going to be where those indices are of those sort of values. And I'm going to have the other indices, what was at index j is now at index 0, and whatever indices were between, whatever values were between I and j, those are now between 0 and j minus I, right? Now, what I'd want to do is then do another reversal, and move j into, it would be position j minus I minus 1, right? Do another reversal of j minus I minus 1. So I can do a reversal from 0 to j, and then 0 to j minus I minus 1, another reversal. Now, I don't really care about the elements in the beginning, what their order is, but I do want to do yet one more reversal a third time to move all of those elements up to what is now index j, what was previously index j, all of those elements back into the beginning. And that would work. That would give me three iterations, and that gives me an inductive step, and that allows me to sort relatively easily. So that works. I just have to find the minimum, the index of the minimum at each step. So it's going to be int I equals 0, I is less than array.size, increment I. Let's find the minimum. So it's going to be int min val is going to be, use a sentinel and optional, min val min index. And we're going to say for int j equals 0, j is less than array.size, increment j. And actually, you could start this off with min val is array of, and it actually starts off at I plus 1, should be. Yeah. Of I starts off at I, and we say this, and we say if array of j is less than min val, then update min val to array of j, and update min index to j. Okay, so that's fine. Now find the minimum, and we say if I equals j, then continue. Otherwise, we're going to say result. You can see this, right? Yeah, that's fine. Standard vector int result dot reserve. Should be like 3 times array.size. Turn result. So what we're going to say here is if they're not equal to that value, then we're going to do result dot pushback. We do k minus 1. So it's going to be 0 to j, so it really should be j plus 1. 0 to j inclusive gets reversed. Then there's another reversal, which is, this is up to, but not including j minus I. So it's going to be j minus I minus 1. J minus I minus 1 gets reversed, but k is plus 1, right? You add 1 to that. That gets reversed, and then you reverse this again up to j plus 1 again. So you do those 3 reversals. So you find that minimum and then perform the reversals required. And something like this ought to do it. And you just skip if I is equal to j, or min index. It should be not j. Yeah, it should be min index. Something like this. Wrong answer. Okay, so case 2 is fine. So this one, I said, okay, we get 3, 2, 4, 1. Let's do the first reversal. Oh, and I think the minimum, yeah, do 1 full reversal, and then I think there actually has to be 1. The first iteration is just whatever the minimum is, just reverse that to the beginning. Do this once, and just say, where this min index is. Do that once, and then continue here. Start this off at 0 and 0, and this is just 1 to, yeah, something like this. Something like this. Okay. So what happens here is we should put 4 in, and we should get 1, 4, 2, 3, I think, and then continue sorting from there. Yeah, 1, 4, 2, 3, and then it would, you'd search for 2, and then and continue reversals from there. I think. No. I don't know what, something's going wrong here. Something's not quite right. Min index is 3, 0, 1, 2, 3. That should be what we get initially, and then here this should update to 1. And then we would say whatever's here, I think, which is 4, right? Should start with 4, and then we look at everything to the right, see if anything is smaller. We should get 2, which is the smallest one. 0, 1, 2 should be index 2. So, oh, I have to actually perform the reversals at each step. Oh, that's very awkward. Whoops, I didn't think about that. Oh, duh. That might have something to do with it. Yeah, I think. Yeah, we don't do 3 reversals for the first one. We just do 1 reversal. I didn't even think about that. Gee. I didn't even think that's, yeah, whoops. Okay, I have to actually perform the reversals too. Sure, that's fine. This is min index, I think. So we do min index minus I minus 1, I think, and min index again. That gets really confusing. Gee. Maybe this is a +1, actually. Maybe this is, maybe I'm wrong about that. I think it is. I'm thinking about it a little bit more. Let's try this. Try these things. Wrong. What is going on? Output 4313. Let me print the array at each step. Getting a little confused here. All right. Oh. What is going on here? One, 4, 2, 3, 1, 4, 2, 3. Okay, 1, 4, 2, 3 is fine. Then the min index and min value is 2. The reversal should be 0, 1, 2, 3, right? There's those 3 elements. And then so I'd get 2, 4, 1. Then I would reverse. It's j minus I minus 1, which is just this element. No. I think I got that one wrong. It's not j minus I. Well, yeah, we only had one element. Yeah, we ended up with, okay. I'm gonna print each one so I can see it. All right, let's try this again. There are a bunch of things going on here. Yeah, 1, 4, 2, 3, 2, 4, 1, 3, right? Reverse all of those, so now 2 is here. Now 2 should be placed here with 2 and 4, should be swapped. The difference between j and I, right? I is 0 and j is 2. Oh. It should be more like I minus 1, I think. This min index, this doesn't happen actually here. This doesn't, I could remove this because I'm always moving to the right of I anyway, right? I hasn't been picked yet. That's what it's supposed to be. So actually this gets confusing too. I think I don't need this. Part of me thinks I don't actually need that part at all. I hasn't been picked yet, right? So yeah, if the min index is equal to I, then continue. Yes, we do want this. Okay. Now that we've picked the min index, we know what I is. I minus 1 is actually the index of things that have been set. So it's not minus I, it's minus I minus 1, which gives you minus I plus 1. Yeah, which is confusing. Which is confusing. I think that might be the issue. There we go. Okay. That is confusing. It is confusing. So 3, 2, 4, 1. Min index is 3, min val is 1. We do this reversal, then this reversal, then this reversal again. We basically just reverse it 3 times, which is very confusing, I realize, but that's that's what it is. I think we do that basically every time. We just do three times for the first element. Next element, we have first reversal. We get 2, 4, 1, 3. The 1 is here, the 2 is there. And then now we want to swap to put the 2 next to the 1, and then swap all 3 of those again. And now we want to put the 3 here. So we're going to reverse everything to get 3. And we get 1, 2 on the right side, 3 on the left side. Swap 4 and 3, and then swap all 4. Yeah, and that should be sufficient. That's like a very straightforward approach. That should work. And here we just skip all the way across. Okay, that's... Gee, I mean, I got there, but boy, was that challenging. I don't know what to say about that other than I don't know what to say about this other than, well, boy, oh boy. Okay, let's try this again. Let's try some other test cases too. Am I doing on time? 30 minutes? It took a while for this. I don't know. I don't know what to say. I have no real excuse here other than I think I got some things confused. 1, 2, 5, 6, 5, 3, 4. And then let's do like 10, 1, 9, 2, 8, 3, 7, 4, 6, 5. Try all of these different scenarios. I get something. Okay, that's reasonable. Okay, again, let's look for edge cases that are unusual. So 1 and 1, it could be. Let's just do 1 and 1, see what I get. Let's do like, 3, 2, 1. Let's do 2, 1, 3. And let's do 2, 3, 1. All these different possibilities. This took me a while, I have to say. This took me almost 30 minutes. All right, I think I'm gonna go for it. Just gonna go for it, see how it goes. Maybe I make a mistake, maybe not. Oh, got there, very good. Nice. Submit this like 5 times. I think I'm gonna take a break after this. It's pretty good. submit this 7 times, I guess. 7 should be fine. And then see if I try to get better than 5 milliseconds. Kind of disappointing that I'm not, not getting, 0 milliseconds or whatever it is. This is kind of a slow solution, it looks like. But I guess it is what it is. Yeah, 3 milliseconds. It's okay. It's not the fastest. This is quadratic time, obviously. I might be able to do this in, what I probably could do is I could probably predict where the minimum values are going to be after the reversals, and I could probably do this in linear time. That'd be my guess, or n log n time, not linear time, but n log n time. I probably could do this in n log n time and get the faster runtime. And what I would do is I would say, after these reversals, do all the elements end up in the same spot that they were in? I don't know. That's a good question. I don't think I actually need to perform these reversals, and I don't think I think I could basically find the min val and min index. Probably could do that more efficiently. I'd have to think about it a little bit longer, but I'm pretty sure there's a way to figure out I don't have to way to do this without performing the reversals and then also not running this extra loop inside, which would make this probably like n log n time. There's like a logarithmic call you have to do at each iteration, or some like have to sort it first or something, and then you can figure out like what this min index is efficiently. You don't need to do this extra work. I would guess that's probably the case. I'm not gonna 1, 2, 3, 4, 5. Did 2 more submissions. I'm not gonna go through that much extra effort for this. This is like, I don't think. Oh, there we go. Got 100% anyway. So hell victory. Hell victory. Got 100% anyway. Didn't even need to. I was gonna say I don't think it's worth it. 1, 2, 3, 4, 5, 6. But you probably could. My guess is you probably could. If I really thought about it for a while. But I don't know if you can. I just think you probably could. Most likely. So yeah. Thank you for watching. I'm going to stop there. Interesting, fun. I don't know what else to say about this other than, it's an interesting question. I want to take a break. I don't know, maybe I want to eat something. I think I ate something already today, but I'm not sure. I don't remember actually what I did. Hi. Hello. Hope you're doing well. I'm actually heading off. Yeah, I don't know what else to say. If you like the video, don't forget to like it. If you like the channel, don't forget to subscribe. And I'm probably just gonna take a break, eat some food, relax for maybe an hour or two. I don't know what to do with myself, quite frankly. I don't even know. I'll probably come back. I'll probably be like, I don't know what to do. So I came back and did more. So yeah, all right, take care.